My name is Sergio Carreño. With my partner, Jose Luis Fonseca, we are members of the on-chip research group for associate of the E3T of the Universidad Industrial de Santander. In this project, it's the focus, principal focus, it's the transition of the levels. Yes, this name for this block, it's the level shifter low to high. Okay, what is the level shifter? Yes, it's very normal for the block in the block on system on chip. It's very normal they have two or more levels of the blocks in different specifics voltage. Okay, what is the real problem for this is the iterations for digital logic blocks. Okay, it's very normal for digital logic blocks in a specific, for example, one block it's for multipliers. Yes, yes, in this multiplier it's very normal for the much iterations. Yes, what is the solutions for this and what is the problem for this? Okay, the solution for this it's basic, the basic is principle. It's the low to the voltage domain of BDD of the one high level. Okay, what is the reason for this? It's the load power presuppost. Yes, it's very important. The low power in this case. Yes, it's the concept. It's for the reduction for the dangers and other iterations. Yes, but the real reason it's a small conception. Yes, for this case in specific, it's the low power energy for the presuppost. Yes, what is the real solution? The real solution for this in this case on the on chips on systems. Yes, it's very normal. Two more blocks. Okay, what is the solution for other iterations, for other blocks, for communication with the other blocks in specific? The solution is level shifter. Okay, the level shifter is the protocol of communication in two blocks, the logics with the different domains. Okay, the specific level shifter is the shank domain. Okay, for different situations. Yes, it's very normal for protocols of communications. Yes, the sound dates that's in a specific voltage. Okay, for this case, the level shifter it's the more it's the same. In for example, it's a translate. Yes, in workflow. Yes, in workflow when the two persons. Yes, in this case, Jose Luis speak in Mandarin. Yes, I am speak Spanish. Yes, I need the translate for communication for two persons. For two persons, it's very essential. With this, the case, it's the four block. Yes, all block. It depends for the all blocks. Yes, for the technology, it's very essential. For the technology, it's very essential for the this.
So we have two principles. Okay, we want to translate the domains. Okay, so we need the topology of the level shifter. There is two important, but we are going to talk about this. This is the cross-coupled topology. These have two sections, two important sections that are the pull-up network, who who will raise the voltage to VDDH, and the pull down network who will lower the voltage to zero. Okay, so when an input of one in low level in 0.2 volts input joins to the transistors will rise to VDDH that maybe 1.2 volts. Okay, so this is the topology, the principal topology. But we choose this topology to implement. Why? Because they have some improvements. Cross-coupled topology have the problem of contention. Contention is that the level shifter isn't capable to translate. So this addition of transistors, these transistors works like helps the level shifter to do the translation good. Okay, so these transistors reduce the strength, these transistors reduce the speed of the pull-up network, and these transistors are the pull-down network. But it's important to say that these transistors are in different technology that they use technology. This is an FDSOY technology, that means a fully depleted silicon insulator. Okay, it's an insulator between the transistor and the silicon. Okay, that has a lot of effects. That is the important characteristic of FDSOI is that the when you introduce a voltage in the bulk of the transistor, the VTH will the threshold voltage will decrease. Okay, and it gives strong to the pull down network, and this is how you equilibrate the strength in the pull up network and the pull down network to avoid the contention problem. We want to the focus of this work is to replicate these circuits made in a fully plated silicon insulator, but in bulk CMOS.
Okay, complementation, this project is the one of principal objects or specific objects. It's the very roast simulation, yes, but it's more for the implementation, real implementation in silicon, yes. This project it's very essential for the new chip of on chip. Yes, this project it's very important for the group, for me, for my partner. It's very important for the quality of simulations, quality of 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 analysis. Yes, it's very important. The real important it's for the implementation, for the sound these circuits of the silicon, of the probe and measure. Yes, this is the real object for this project. Thanks.
I got one question. Jose just mentioned that you're trying to replicate a work that is already developed. How can you tell us what's the improvement about it? The problem is that this university doesn't have this technology. We work with a common technology like books and MOS. FDSOI is niche, okay? Isn't common to use in the industry of electronics. So the object, how I say it, is replicate the low power characteristic of this circuit in books and MOS.
Yeah.
This is
Yeah, for the complementation, the technologies, this technology builds a most, it's more cheaper for the other technologies. Yes, this technology it's very expensive. Yeah, the real reason for this expensive is for the manufacturing process. Yes, the separation with the silicon and the bulk, it's very expensive, and the process it's more difficult. Thanks.